The ARPDC respectfully acknowledges that we are located on traditional lands across the province of Alberta on Treaty 4, 6, 7, 8, and 10 territories. That's the traveling route, gathering place, and meeting grounds for Indigenous peoples whose history, languages, cultures, and traditions continue to influence our vibrant communities. We are grateful for the traditional knowledge keepers and elders who are still with us today and those who have gone before us. We recognize the land as an act of reconciliation and gratitude to those whose territories we reside on or are visiting. Who am I? I am Yolana Seletsky, and I am coming to you from Edmonton. And I am a retired math teacher and math consultant from Greater St. Albert Catholic Schools. During my time as a consultant for Greater St. Albert Catholic Schools, I also work for Edmonton Regional Learning Consortium, and that's who I am here on behalf of today, the ERLC. And then when I retired, I continued contracting myself out as an independent contractor with ERLC. During my last about 20 years of teaching and working with as a consultant, I also worked with Pearson Publishers as a reviewer for their Math Resource methodology, for the math learning progressions, and I also did a review on a book that they wrote on fractions, rethinking fractions. And so I kind of dabble in it, and anyone who knows me knows I think I'm pretty passionate about anything that has to do with math. I love math, and I really believe we could all love math if we understood it. I'm a mom of 3 young ladies, and since I've retired, I've started to travel. And last year, the 3 pictures at the bottom are from my trip to the Tahitian Islands, and where I swam with sharks and enjoyed my first time away being retired, and got to go during school days, so I didn't have to take any time off, and that was a real bonus. Before we start today's session, what I want you to do is draw a rectangle and partition your rectangle into sixths, and shade in 5/6. We'll come back to that activity after, but you can do it any way you want to do it, but just shade in 5/6 of your rectangle. One of the things I did tell you about already, I did do a little bit of review work on Pearson Math Learning Progression, and I really love the math learning progression because it is a step-by-step look at the stages that our students and we go through as we build skills in any strand in math. They are organized, she's organized it by strands, and then by the big ideas within each strand, and then each big idea has conceptual threads, and then within the conceptual threads that span from kindergarten all the way to grade 9, there are indicators of where people are on that path towards mastering the understanding of a certain conceptual thread. I am so proud to say that it was written by Dr. Lynn McGarvey, who is from the U of A, so a very local person. And, you know, Dr. McGarvey is amazing. And I've had the opportunity of working with her shoulder to shoulder and really coming to understand a little bit more of these progressions. So just to give you a bright, actually, I didn't, I took the slides out, I forgot. No, I didn't. They're here, they're coming up. This is out of order, but that's okay. The other thing is Isabel is here, and Isabel is one of my colleagues from the French Consortia, and Isabel and I worked on this here, which is just a what's the word, Isabel, of this? You're on mute. You're on mute, Isabel.
Sorry, I just work on that in French. Portée et séquence. It used to be in the old program is just to see the sequence of let's say number, what they do in kindergarten and grade 1, the progression of it.
Okay,
The English term, it escaped me right now. It'll come back, sorry.
okay, whenever it comes up, you let me know, because it's gone out of my head too.
I'll put
Anyway,
it down in the chat. I'm gonna look. Okay.
okay, thank you. Anyway, so these are the progressions of how in the curriculum, how we learn the different things with fractions. So this is really important for you to look at, because you are the grade 6 teachers. Scope and sequence. Thanks, Larissa. This is the scope and sequence of
Yes.
how the knowledge of fractions is built in grade kindergarten, in grade 1 to 6. And so your students have not had any of this new curriculum, and so they have not taken what is a half, what are unit fractions. They have dabbled in fractions, but not really as well laid out as it is in this curriculum now. And so this curriculum, and then also your kids, are behind anyway, because they are the products of COVID, that they've been out of school. And a lot of times teachers had to drop things out of like, well, I can't teach this because I don't have time. And sometimes it was the fractions they didn't teach. So anyway, now in grade 1 to 3, and I know that when it first started, when it first came out, we all shook our head and said, how can we be doing fractions in grade 1? Like, come on. Larissa, I know you taught grade 1, and you're probably thinking yourself too, how can they be doing fractions? Well, you know what? It really is a simple concept in grade 1. What's a half? That's it. We use that language all the time, but what the most important thing is that they learn is that it's 2 equal groups, not just something that's cut into 2. In grade 2, they talk about unit fractions, and I love the fact that this is in the new curriculum, because unit fractions, you will see, are extremely important, and we'll go through what they are and help you understand it so that you can use the term in your teachings in math. Equivalent fractions, and that is they looked at compositions of unit fractions limited to denominators up to 12. And not only did they do equivalent fractions with common denominators, but they did it with common numerators also. And then in grade 4, it is equivalent fractions created by partitioning the given fractions into smaller fractions and recognizing the simplest form. And then the biggest one, that like one of the things that I am in love with, is that in grade 4 now, they actually convert decimal fractions. And we'll go through what is a decimal fractions and why is that so important. Anyone here come to my session on place value on decimals? Okay, I see one person. Then you know what decimal fractions are right now. You've already gone through that with your in the decimal workshop. And then grade 5s now do improper and mixed numbers. And then you do fractions representing quotients, and you convert fractions to decimals using division. The other thing that is new, and this is huge because anyone who has been teaching, oh, good, Carolyn, nice to see you back then. So grade 5 and 6 now, you do adding and subtracting fractions. So last year, if they would have had the new curriculum last year in grade 5, they would have been adding and subtracting fractions that have common denominators. Because now you're going to be adding and subtracting fractions without that common denominator. And then the big thing is, and by the way, that used to be in grade 7. And so now it's down to grade 5 and 6. But you'll see that if things are taught properly throughout the whole, like from grade 1 to 6, by the time they get to you in 5 years, you'll be okay to just do addition and subtraction of fractions without that common denominator. And then another big difference for grade 6 is that you're actually going to be doing multiplication of fractions with a natural number or a whole number. And so you're going to relate the multiplication of a unit fraction to division. Now, that used to be in grade 8. And now it's down in grade 6. And I can tell you from being a grade 7 and 8 math teacher for 20 years, I didn't think my kids were ready for it when they were in grade 8 or grade 7. But they also, the teaching of fractions was not as broken down as it is in today's curriculum. So the other thing is that now you're doing more with rates. And so you'll notice on this scope and sequence that anything that is highlighted is new for your school year, is new for you in grade 6 or grade 5 or grade 4 or grade 3, anything. So if you look back here, you'll see everything has been moved down and it's new in every year in fractions. And then from Dr. McGarvey's book, these are the progressions of how do kids really build their understanding of fractions, and they go across. So it goes from, here it says visually comparing fraction size and names, example halves, and it goes across this way, and then it comes down to the bottom and goes across just like a letter Z or Z. And when I really looked into this, and I looked into our new curriculum from grade 1 to 6, yeah, it actually flows really quite nicely on this. The only thing is, I'm not quite sure yet that our students are cognitively able to do all this work in 6 years. But time will tell. Time will tell. So these progressions, I love them because I'm just going to pull one of my books down. Like, for example, if I was to open it up in my book, it just goes across like this. And so if I knew that I was working on, for example, in grade 6, adding and subtracting fractions with unlike denominators, I could go and say, okay, they're supposed to be here in that they're understanding. Where is it that they might be behind? And so I really like this progression because it helps me with that. And anybody who's using the Mathology book resource, you'll find that all the lessons are built according to the progressions. Now, the other book that I really love and I used a lot of is this one here. It's called the Rethinking Fractions. And what I really like about this is the ladies are, first of all, it's a Canadian book. It's Catherine Bruce, Tara Flynn and Shelley Yearley wrote it. They're from Ontario. Pearson Publishers contracted them out. It took them over 10 years to write. Every time they did any studies, they kept revamping and revamping and revamping the book. And at one point, they actually thought that they're gonna need to write this in as 8 books. But then they brought it down to 1 book, and it really is amazing because I like this as a metaphor, because the gears, if the gears are not well greased, things are going to stop working along the way. And so here you're already going to be working with adding and subtracting fractions. If any of these gears lower down have broken down, we're going to have some issues. So I am going to take the first, I'm going to try to get this done, the first part, in like 20, 30 minutes max, about what they should already understand about fractions when they come to you. By the way, you will be receiving all of these slides, and you'll be receiving links that go with these slides. And so anything I talk about, like rethinking fractions, there's a link to the book if you're interested in it. And I'm just going to say, I'm going to give you a quick rundown of the key findings and the things that jumped out at me when I was reading this book. But key findings that these ladies found from research, which should inform every aspect of our work when we're teaching kids at every level, is 1, the importance of unit fractions. And Isabel and I had a huge discussion about unit fractions yesterday, as when we were teaching, that was not a big issue. And now I realize how important it is. The other thing that's very important is the precise and powerful representations. that we use when we're using fractions. Precise language is super important. And so is providing our students with rich opportunities to build conceptual understanding. And I have to tell you, even if I know that a lot of people send me emails after sessions and they say, you know what, Yolanda, if only I had the resources. I don't have the resources. We don't have this. We don't have that. You have to know that we have put together some great resources for you on the ARPDC website. And I will be giving you a lot of resources today that I have found that you can use. You don't need to have purchased anything, but boy, if you do have, I would say if you have Math Up or if you have Mathology, you're really set with great resources. But if you don't have those, we'll give you access to some other stuff, but that'll give you information on rich opportunities so that you can build that conceptual understanding instead of just giving them rules. So the first thing that I want to talk about is precise language. And this was one of my, I'm not sure if is there anyone here that was here yesterday, by the way? If Isabel was here yesterday, because I did a session with grade 5s. So you'll see some of these slides are the same until we get to the grade 6 material. But anyway, this is my biggest downfall. If I could go back and redo the 20 years of teaching in math that I did, I would make sure, number one, I started using precise language when I was teaching. Read the fraction as a number, please. It is, if you see the 2/3, you could please say 2/3. We can even say 2 1/3. That is way more precise than 2/3. 2/3 is a positional language. 2/3 describes the position of the numbers, not the quantity. It would be like me if I just said a number like 341. And I assume you're going to know that that's 341. It's not 341. It is 3 digits, 341. Just like 2/3 is 2 digits, and I'm telling you one is over the other. That's all. Also, that is a positional type of language. And the other thing that I had an aha moment when I went to the workshop with these ladies from Rethinking Fractions was they said, please don't say 3/4 or quarter, 1/4, 2/4, 3/4 when you're dealing with fourths. The reason is we all bring our pre-existing knowledge when we hear to math. And if we know that a quarter is 25 cents and we've never dealt with fractions before, we think of the quarter. And so when I say 3/4, kids will think of 75 cents. We want to say 3/4. We want to say 3/4 because it gives it a value. And you'll notice with precise language, we are giving value to a number. You guys would not believe how many kids would come to junior high and ask me, is a fraction a number? Yeah, it is. And then when we tried to put it on number lines, they didn't even know you could put it on a number line because you know what? It did not make sense to them. How would they know where to put it? Because they've only heard it not correctly. Okay. Also, we don't say 2/3 or 3/4 because that also constructs fraction as a subtraction. We all do use that language though when we're talking ratios, but ratios and fractions are two different ways of writing. One is one of writing a part of a number, and the other one is to write a ratio. And so we have to be very careful when we are teaching that kids understand I am talking about a fraction or I'm talking about a ratio. Also, speaking like this 2/3 as a fraction, that doesn't extend itself to improper fractions Like, for example, if it was 11/3, how are you going to say 11 out of 3? Huh? What does that mean? Okay, so another one is key representations of fractions. Over the years, they should have been using set models, like a fraction of a set. For example, there's the red is 2/8 of the set. In lowest terms, it would be, or in simplest terms, it'd be 1/4 of the blocks are red. The linear model or the length model is really great if length model is if you're drawing it on paper, or if you're using, a rectangle on your board. But great for the linear or length model is Cuisenaire rods, if you have them in your classroom, and I know some of you do. And then the number line model, kids should know how fractions go on a number line. The volume model is when we are dealing with even cooking or in science. We talk about, half a liter. We talk about a 1/4 of a liter, 3/4 of a liter, 5/6 of a liter. We also talk about area models. And you'll notice that I put down rectangular area models. They can be square area models, but just out of interest, the reason I love the area models is because they lend themselves really nicely to multiplying fractions, which they'll do in junior high, because in grade 6 you're multiplying fractions, but you're multiplying a fraction by a whole, not a fraction by a fraction. Okay, so the array is an awesome one when they start doing when they start doing fractions by fractions. So everything lends into itself nicely. But what am I missing here? Anyone? You can put your mic on and speak, or you can put it into the chat. What am I missing?
Pie chart, pie 1.
A pie? Is that what you said?
Yeah.
Yes. I missed the pie. I didn't put in the circle. There's a reason. It is a problematic representation that I would say try to stay away from as much as you can, especially in grade 6. They do them in junior high. Why is it problematic? It's really hard to draw exact portions when you are doing a circle. It's really hard to draw an exact circle also without using a protractor. And if you were doing fractions of a circle, then you also have to measure the angles to make sure they are exact. And we're not so good at that. So those become very problematic, because when we say a half of a pizza, or half of a donut or half of an apple, we mean exactly the same amount. And like half an apple be exactly half the mass. Whereas it's really hard to cut those exactly in half. And so what we have to do is we want to make sure that what we do is we stay away from them because of those problems. So one of the things is I'm going to show you a quick video. In your links that you'll receive today, there is a bunch of videos put out by Origo Math that talk about fraction models, and this one just does an overview of all the models, whereas there are separate 1-minute videos on each type of model. So I'm just going to show you this one for now, and whenever I show these in class, I just will skip ahead about 6 seconds because they're all the same first seconds. So I'll just go.
What models should I use to help my students to better understand fractions? In the early grades, we explore fractions informally by partitioning 2D shapes into parts of equal length. Each part of this rectangle is 1/2 because it is 1/2 the length of the whole. We also use an area model. Look at this circle. I can call this part 1/2 because it is 1/2 the area of the whole. The number line is a special kind of length model. Here, the whole is the distance between 0 and 1. I would show 1/2 at this point because it is 1/2 the distance from 0 to 1. The first three models use a continuous measurable quantity. The set model has a discrete countable quantity. Look at this carton of eggs. I can count 12 eggs in this carton, and 1/2 of the total number is brown.
Wow, I can see the need for 4 very different models, and the language I use is unique to each model.
So now, one of the first gears is estimating proportions. And so I just want to, this is something they should have already done in the previous years, but this is an example of something that you could show, and you ask if A is the whole, and what fraction would B show of the whole? And in this book, Rethinking Fractions, super easy. They have a bunch of assessments. This is one of them. And this one also gives you, how would you grade this? And they do a scale of 0 to 3. So I want you to think about, if you were to do this, how would your students do this, or how would you do this? And just to yourself say, what fraction does B show if A is the whole? Well, according to the studies that these ladies did, some of the kids just did that, gave an answer. This, and it's wrong. And this student would have got a 0 because it just looks like they guessed. There's really, I mean, I could say, okay, I would ask the kids, well, how did you come up with that? But you want to see that there's some thinking rather than just not guessing. This one is another example. And the student actually did the marking and then said 2/3. And well, why? When they were doing this, what they did was they said, well, this is 3. I cut this into 3. And so this is going to be 2/3 of 3 pieces. So this one gets 1 out of 3 in that they put the markings, they're not exact. And the thinking, if these were exact, that would have been the right answer. Another one is this one here was beautiful. When I looked at it, yep, this is exactly it. First, the student cut it in half and then did the other parts in half and said, guess what they said? 1/4. And it was like, what? Well, what they did was they actually got, this was a 2 out of 3, because what they did was they named the missing piece. So they may have given the wrong answer because of misunderstanding the question. Now, because I'm on this slide right now, I just want to turn your attention to something. We do not write fractions like this with the diagonal. Now, this is why this presentation today took me forever to do. When you see that, that means I was running out of time and I just had to do this fraction, but that is incorrect. I am telling you right now, it's incorrect, and I'll tell you why very shortly, why that is incorrect. So the correct answer for that is actually 3/4. How many of you figured that one out when I asked you what fraction of A is B? 3/4. Okay. And you know what? I have to tell you something. It's okay to make mistakes. It's okay to be wrong. Now, Isabel knows probably exactly what I'm going to say right now. Yesterday during the session, I made a slide and I made a mistake on the slide. And then everyone left. And Isabel stayed at the end and said, Yolanda, you have to help me understand what you meant by that. And I look at it, it's wrong. That's what I meant. It's wrong. And the best thing is when kids can see, you know what? I made a mistake because they think you're perfect. And good God knows I'm not perfect. Right, Larissa? You know what? And I don't know it all. And I have made a mistake. And it's okay. So please know that I value mistakes because we learn from our mistakes. I can tell you, I will not make that same mistake that I made yesterday again in a presentation because I know what I did. Okay. Another gear in rethinking fractions and something that we teach through in earlier years is to equally partition area, linear, and set models. So they name and count the partitions, and then they further unit fractions to develop an understanding of density. And density of fractions means that there's infinite amount of fractions between any two fractions. Just like there's an infinite amount of numbers between any two whole numbers, there's an infinite amount of fractions. You can keep cutting down that fraction into really tiny, 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 tiny pieces. Just like we were talking about decimals last week, you can keep cutting that into smaller and smaller pieces. Now, one of the bigger things that I want you to know is really, please allow your students to do the partitioning rather than giving them a pre-partition model of something. That, for example, I asked you to draw a rectangle and partition it into 6. And I asked you to shade in 5/6 of that. That is a much better task than me taking a rectangle, cutting it into 6 equal spots, and then telling you, could you please color in 5/6? We can train our kids to get the right answer for the wrong reason. We want kids to get the right answer because they understand. So here is that question. It comes from this book. Partition this bar into 6 and then use it to show me 5/6. And it comes from the unit on equally partitioning area. So this is how some students answered, and this is how they graded them. 0, student got 0 if they didn't even give an answer. A 1 is they just randomly put a line and said 5/6. And this little red line or purple line is where 5/6 really is. A 2 out of 3 is this one here. This student actually did partition the bar into 6, but they're not equal partitions, and just wrote 5/6. Whereas this student here actually did partition that bar equally and wrote 5/6. So this would be a perfect answer. And so because this question is about equal partitions, the precision is very, very important. So now looking at your bar, what would you give yourself in this here? Okay. Some people say 2. Anybody give yourself a 1? Did anyone give himself a 3? I had someone once when I was doing this session before with the 3 at this, someone gave himself a 3, and I said, how did you give yourself a 3? Like, what did you do? And she goes, I was doing this on graph paper, so I could count, and I was using centimeter graph, and I did it 6 centimeters, and 5/6 was 5 centimeters, and I went, perfect. And then yesterday we had a discussion, because this is part of grade 5. How else could we do this without a ruler or without graph paper? Anyone? You could do this using paper folding. Paper folding is extremely powerful. Do paper folding in your class to show fractions, and this is where you can really stress the importance of being exact. Okay, so like I said, how would have you scored on your own? Then we go into grade 2. Okay, guys, all that was done in grade 1 and 2. And now the other thing that we have to do, they did in grade 2, is unit fractions. And unit fractions, so if I take something like this, is I broke it down into thirds. Now, if I go back to this, I broke it into sixths, and each one of these would be a sixth. 1 1/6, 2 1/6, 3 1/6, and I can see that 3 1/6. 3 1/6 is equal to half. I could see that by just looking at this. 4 1/6, 5 1/6 is here, and 6 1/6 makes a whole. Now here, if you just take a look at how they count, 1 1/3, 2 1/3, 3 1/3, and I can see 3/3 makes a whole. 4 1/3 is bigger than a whole. 5 1/3 is bigger. 6 1/3 gives me 2 wholes. This is called unit fractions. Counting by unit fractions is super important. And what I want to do is just let you know that, oh, this was horrible. How come? Okay. It helps them understand. And you know what? I tried to make my slides pretty, and look what happened. Yeah, I didn't check them all before today, for the presentation. I was finished at 3 o'clock this afternoon. Anyway, counting by unit fractions helps students understand that fractions represent quantities, helps them build an understanding of improper fractions and equivalent fractions, and it is a precursor to addition and multiplication of fractions. Explicit use will also help, should have, of unit fractions. So kids should have the experience of composing and decomposing part whole fractions using unit fractions. Like, for example, 2/5 is 2 1/5. 3/5 is 3 1/5. 4/5 is 4 1/5. If I had 7/8, I would know that it is 7 1/8. And so I put this slide in because Isabel and I had a really good discussion about, when we were teaching, we never really taught those unit fractions before. And so why is it important? Well, when we are doing things like whole numbers, we say 5 plus 3 with the understanding that we're talking about 5 whole units, or 3 whole units will give me 8 whole units, which is 8. When we're talking about adding decimals, we say we have 5 1/10 units plus 3 1/10 units, which is give us 8 1/10 units, which is 8/10. But when in algebra we do 5x plus 3x, the x is the units. 5x units plus 3x units will give us 8x units. In the kitchen, we might be using teaspoons. So we say 5 teaspoon units plus 3 teaspoon units. In the garage, or for measuring, like Larissa was measuring lots this weekend because she built her own beautiful coffee table, Larissa. You measured by units, millimeters. So 5 millimeters plus 3 millimeters, you use units. And that's why we really want to make sure that kids understand what they're adding, like 5 9ths plus 3 9ths. This is a grade 5 concept. Your kids miss this. And so you'll have to help them understand 5 nines plus 3 nines. All you're doing is you're adding 5 1/9 units plus 3 1/9 units. So what you end up with is 8 1/9 units. And that gives you 8 nines. Don't skip that point. Okay, Isabel, you had a question.
Now I have two. Okay.
Okay.
Sorry about that. You know, the one before, like 1 1/3, 2 1, like this one, 2 1/5 unit. What happened if the kids say it's 2/5?
Then
There's a,
do they understand? Okay, you would want to ask them, why is it 2/5? What does
Okay.
that mean?
why is it 2/5? Show me why is it 2/5? Okay.
Yep.
And if you go to the, okay, just because I know some kids are already very okay at fraction, they would call it 2/5. Like
Yep.
this one, the third square, the fraction, that's a 5 on 5 9 plus 3 9, 5 1 unit 5, how do you call it?
1/9.
5 1 9. When I see that, for me it's confusing because I see 5 whole and 1 9.
You say 5 and 1/9.
I see 5 and 1 9 plus 3 and 1 9 would give me 8 and 2 9. That's how I see it.
Okay. Well, you want to make sure that they understand that what we're doing here is we're adding 5 1/9 units, like 5 nines. Just
So
so
would-
that just like this millimeter units.
Okay. So would that be better just to write it in words then? 5 1 9.
Oh, sure.
Because
Absolutely.
for me, for
Yep.
my understanding, that for me, I can see how it would confuse kid because they would think there would be a fraction with a whole number and a fraction, and then they
Yep.
okay. I was
I
just
like that using words. I just did this really quickly.
no,
just so
no,
that I could
it's
give you an example.
no critic. I just wanted to make sure I understand well.
No, but you're
Okay.
right. Maybe use the words instead. Another one, another gear, and another thing that they have done in grades 1 to 5 is decomposing fractions. Like, for example, in grade 1, we decompose whole numbers. We say, how many different ways can you make 7? And they say 1 and 6, 2 and 5, 3 and 4. This is the same thing here. How many different ways can you make 3/4? So they could say, well, 3/4 is the same as 1/4 plus 1/4. I could make it with a half and a quarter. But in up to grade 5, they haven't done this to do adding. They've just done this to know that there's different ways of decomposing a fraction. And I love using Cuisenaire rods when I'm doing this, but that is one of the things. This really provides the groundwork for the last 4 years. Another one is partitioning unit fractions to make a smaller fraction so the kids see that there's an infinite amount of fractions in a fraction. So for example, like if I have something that's 1/5, I can break that down into tenths. I can break that down into 4/20ths. I can break that down into hundredths. But just so that they can see that unit fractions can also be broken down. They're not the smallest fraction. This really leads kids into the equivalent fractions and comparing fractions. In grade 3, they do comparing fractions. Now, this part is very new in our curriculum all over the place, not only in grade 3, but this is new in that convince me that 4/6, no, first of all, is 4/6 less than or more greater than 4/5? Anyone?
Well, I'll say the mistake I did yesterday.
Okay.
And sometimes we learn good by mistake. And when I was looking at that, if I look at 4, instead of looking at the fraction as the whole number as a quantity, area, I just look at numbers separately. And I
Okay.
was looking, okay, 4/5, 4 would be closer to the whole. So
Okay.
that means it would be bigger. But I know that's not the reason, that's not the real explanation of the
That's
fraction.
good though. But you know what? I just, before you go on to your next part, I just want to say, you know what? That's a reasoning, and that reasoning works. But what I want to show in this one is that they're common numerators. They're not common denominators.
Mhm.
And so if we have common numerators, is there a way that we can tell if the fraction is smaller or larger? Isabel?
Well, I always go for a chocolate bar. If I have a chocolate bar, the same size of chocolate bar, one split in 6 pieces, the other one in 5, I prefer the one with less pieces because my piece is going to be bigger.
Okay.
Take chocolate
Perfect.
because I love chocolate. So, and I was lucky enough when I was teaching fraction, we talking earlier in my career, we had the right to bring food in class. So fraction was easier to understand.
Okay,
with
so
chocolate.
4/6 is less than 4/5.
Yeah.
And one of the explanations is why? Because those pieces are actually smaller. Whoops. Right? So 4/6, because those, in order to be a whole, I would have still 2 pieces over here. So 4/6 is less than 4/5. And then the other thing is, we want kids to know that the same fractional quantity can be represented with a whole lot of different fractions. And we say that fractions are equivalent when they represent the same number or the same quantity. So convince me that 4/5 is greater than 2/5. Well, this is what one of the ways you and I have always been trained to use when we have a common denominator. We can prove this. How can I prove this? Well, I can just say because 4/1/5 is more than 2/1/5, or 4/5 is more than 2/5. Make sense? Oh, I wish I wouldn't have tried making my slides so pretty. 7/4 is more than 5/4. Why? Because take a look, it is. If I have 7/1/4 and I just compare it to 5/1/4, obviously I have more 7/4, correct? So, oh, I can't believe this. Convince me that 3/5 is less than 3/4. Again, it's not a common denominator, but it's a common numerator. I have to fix these slides. 3/5 is less than 3/4. How do I know? Well, I can see it is because if it's cut into 5 equal pieces, those pieces have to be smaller than if it was cut into 4. So 3/5 is much small, not much, but it is smaller than 3/4. How about 5/7 and 5/8? Well, I can tell you that, oops, this is wrong. 5/7 is greater than 5/8 because if you cut it into 7ths, you can see the 7ths are bigger than the 8ths. And if I do this, then 5/7 is more than 5/8. Now, this drives me crazy that these slides are wrong. Made a mistake. Have to fix that. Now, anything, if you want any further, and now I'm looking at a note. Carolyn, I love the fact that you're asking kids to use centimeter grid paper. I hope that helps. Yes. If you use grid paper with fractions, and especially with area and with partitioning, it should help for sure. And I'll show you also how you can use those Cuisinart rods on there on centimeter grids. Okay, I just want to tell you, if you want real more information and get a really deeper understanding of fractions, Pearson is having a workshop on November 16th, 30th, and 14th for grade 2 to 9 teachers. And it starts at 4 till 5 o'clock, but it's 3 days. And it's just building an understanding and using their book. And because it's not part of the consortium, it is $100. And it's with the 3 authors. Okay, and I put a link in the sheet that I'll be sharing for that. In grade 4 now, they apply equivalence to the interpretation of fractions, and we relate fractions and equivalent decimal numbers to their positions on the number line. And we also express fractions as decimal numbers. And that's why I asked who was here for my decimal and place value workshop, because I just want to ask a question. What's a fraction? Number one question we ask our kids every single year. We go right back to what is a fraction? And what is a fraction? Anyone?
Kids would say it's a number over a line over another number,
Okay.
without really understanding why is it that way.
Okay. Larissa says it's a fraction is a part of a whole. Larissa, you're absolutely right. It is a part of a whole. But you're right, Isabel. Kids will give us all sorts of answers. Now, the other thing is, my next question, what's a decimal then? What is a decimal? Anyone? Isabel says it's part of a whole. It absolutely is part of a whole. So then, that's what a decimal fraction is, how we can help our kids understand decimal fractions. So a decimal fraction is a fraction where the denominator, that's the bottom number, is a power of 10. It's either 10, 100, 1000, etc. This is where your precise language is extremely important. So just an example, I can say that fraction as, and I should say it properly, it is 5300ths. But if I say it's 5300, so is that decimal. It's also 0 and 5300ths. And notice I used the word and, because the decimal in Canada is an A, is and. So we have and. And okay, sorry, Marilyn gone already. Okay. So it's 5300ths or 0 and 5300ths, meaning there's no whole, but there's 5300ths of the whole. And so these are things I want you to take note of. And this is a beautiful thing you can blow up and have in your class as a poster. As a decimal, this is 0 and 1/10. In words, it's 1/10. As a fraction, it's 1/10. 100 is also as a 0, at 0.01. Don't say 0.01 because that is positional language. That's like saying 100 is 100. No, say the what it's worth, 100, or this is 100th. Those of you who have any students that are from different countries and you're dealing with English as a second language, you really need kids to understand this is different than 100. It's 100th, and then there's the 1000th, and then etc. So those are decimal fractions. So one thing you need to know is there is no area of elementary school math that's as mathematically rich or cognitively complicated and difficult to teach as fractions. That's been for decades, not just this year because you're doing a new curriculum. It is the #1 unit that we reteach every single year because we don't do a good enough job teaching it in the first place. So key ideas from grade 1 to 6 is that #1, there's no such thing as a larger half if we're talking about the same whole. Rectangles are way easier to partition than circles. Have the students create the partitions. Language matters. Please say the fraction properly. Like, for example, 1/2, not 1/2. Make life connections to life connections to the fractions. Fractions can be area, length, sets, and then later, especially in grade 6, we get to rates and ratios that can be written as fractions, but they're really not fractions because they're not showing us part to whole. So the other thing is, I love this. When can the same fraction, like 1/2, be of a different size? Anyone? When can 1/2 be of a different size? Oh, beautiful, Carolyn. That's exactly it. It all depends on the size of the whole or this thing being divided. This is why I love fractions at Halloween. Bring them out. Bring out all the different sizes of the chocolate bar. Like the Kit Kat that you get in the Halloween thing never satisfies me. But anyway, you know, it only has 2 of those fingers, whereas their whole Kit Kat, like the regular size, has 4 fingers. So 1/2 of that chocolate bar compared to the 1/2 of the little one that you get at Halloween. And then look at this one, this big Kit Kat that is actually the size of 2 whole chocolates. So if I gave you 1/2 of this one, you're actually 1/2 of this is equal to 1 of those. Or this chunky one, 1/2 of that one might be the same mass as this one, but may look different. This here, this round Easter egg at Christmas, it's round Easter egg at Easter time. The 1/2 of that is way different from this. And then what about Kit Kat that made this beautiful guy with his little head? And okay, well, if I give you 1/2 of that, even though it's got 1 chocolate in there, it's made with more chocolate. So obviously you're going to get more. So yeah, it all depends on what you're talking about. So this 1/2 is less than this 1/2. This 1/2 is less than this 1/2. This 1/2, I don't know how it compares to that 1/2. I would have to really do a lot of measuring. So one of the things I want to bring to your attention is pattern blocks. So what we're going to do right now is I'm going to just switch to a different slide, which I'm going to give you these interactive slides in your package today. And we're going to just talk about using these pattern blocks. Loris, do you have these in your class, pattern blocks? No? Okay. These are, people use these for fractions, but people get hooked on the fact that the hexagon has to be the whole. So if the hexagon is the whole, whoever this is moving this around, can you just stop for a second and let me move? You'll notice that I gave you blank slides at the bottom, so you can use those after. You can make copies or whatever. But if this is the whole, what is the hexagon? I mean, sorry, if the hexagon is the whole, what is the trapezoid? Okay,
Half.
someone,
Half of it.
I don't know, someone,
That's half.
sorry, it's what?
It's half.
Yes, it's half. So I'm going to write that down. It is half. Well, if the yellow is the whole, what is the blue? I'm not sure. I can.
It's 1/3.
It's 1/3. Perfect. Because I would need 3 of them to cover the whole. Okay, then what is the triangle?
1/6.
Perfect. Now, this is where, as a teacher, I used to get stuck all the time and just say, just use the yellow as the whole. No, I want them to think. So now we're going to go on to this one. This is slide 2. If the red is the whole, what is the yellow in comparison to the whole? Oops. Anyone? This is 1. 2. Perfect. It's 2 holes, which is written as 2 two holes is written as, and I'm talking positional language, 2/1. Okay, then if this is the hole, I'm going to skip this one because this is a little bit hard for now. If the red is the hole, what's the green? How many of these greens do I need to cover the hole?
3.
Right? So what is the green as a fraction of the whole?
1/3.
1/3. One third.
1/3.
Okay, it's 1/3
Oh.
of the whole.
Okay.
So then, because it covers 1/3 of the whole. So if I know that, take a look. What is the blue then? How much is
Sorry,
Blue to green. Blue
no,
to
the
green.
blue- Say it again.
Are you asking how much is the blue to green?
No, blue to red.
red being the whole.
Yes.
Okay.
Yes, Carolyn and Meredith, you're right. It is 2/3 because it's actually the same size as, now let's get that unit fraction out here. It is two, this is the 1/3. It is 2 1/3. 2/3. Okay. Make sense?
Makes
Mhm.
sense.
Okay, then let's go to the next slide. What if the blue is the whole? Let's start with the green. What is the green as a fraction of the blue?
1/2. 1/2.
Half. Okay, language is important. Let's try to use it. It's 1/2. Then what is the red?
What is the
This is 1. This is, so what do we get?
2/3.
No. Good try. 3/2.
3/2. Okay.
Okay, so because if this is a half, that
Oh,
blue
yes.
is
yes.
3/2.
Mm-hmm.
And then what is the yellow then?
3.
3 holes. Okay,
I
here's
put,
one.
okay, I put in the chat for those who don't have that. I put in the chat the an app that you can play with that and put them together and third them as well. Something that you can use directly in class. Like,
Okay,
okay.
thank you. Actually, I'll put that into our slides, not slides, our things after. Okay, I better get moving here because we only got 25 minutes left. If now, what if the green is the whole? Are all these bigger than the whole?
Yeah.
So how many greens fit into this blue? 2. So this is 2 holes. How about here? The
3.
red,
3.
3.
3 holes. And how about here?
6.
Oops. Yes, 6 holes. So these slides you can play with. If you go to here, you're doing this with your kids, you can just make a copy of number 8 to 11 and you can play with these in your class. These are yours to use. Then Cuisinart rods are another beautiful tool that you can use. And if you're using your Cuisinart rods, you could say, Now this is, I'm giving you the Pearson one, and you can use these. But for right now, I'm just going to show you how you can use them. But I love my Cuisenaire rods. They are my favorite fraction tool. And like, just like the yellow pattern block, I like to start with the orange one to be the whole. So if that's 1, then what is this one? It is 1/10 of the whole. Why? I need 10 of them to make the 1. I'm just going to move this up here. Then the red one is equal to 2 1/10. And now I can also start working with equivalent fractions. It is the same as 2 1/10, which is 1/5. The green is 3/10 because it is equal to 3/10. This one is 2/5. Now it is the same thing as 4/10. See, I can put this down as 4/10. And then I can also show that that pink is the same as 2 1/5. 2/5 is equal to 2 1/5, which is 2/5. And I can show these. Now I can also take off the numbers by pressing this. And I would have to, this would help me with helping the students, because when you're looking at your rods on the table, they don't have numbers. But Carolyn was the one that said she had the students bring in graph paper, right? Right, Carolyn? I think that was you.
क्या करता है बिट्टू?
Okay, so here, look at this. 1 centimeter grill paper. What you're going to find is that these blocks are all either 1 centimeter. So this is why it's 1/10, 2 2/10, 3/10. And I can just go and do this one. And without even knowing what it is, I can put it on my graph paper and I can see, oh, that didn't work. And it's because it's probably, probably have to bring it down one. Okay, I'll bring this one down. And okay. So if I'm comparing it to the whole, I can see automatically 3/10 are missing. So it's got to be a 7/10. Let's see if it is. And this is my whole. Oh, something's happening here. I got too many pieces on here. That's why. Let's just see if this is my whole. That black, yes, it is 7/10. But the nice thing about this is, just like the pattern blocks, I can change anything. I could say, this is my whole. If that's my whole, then what is this one? Why? Because now my whole is only 8 centimeters long. And that would mean this is 1/8. This now is 2/8 or 1/4. I can now see that this is 1 1/8.
चलो साफ अब जाते बेटा, मैं वॉशरूम जाके आती हूँ, ठीक है? मैं वॉशरूम.
Okay, this is 1 1/4. Why? Look at this. 1, and this is from decomposing fractions. 1 1/4. Okay, so I do give you access to this tool when you because anyone can use this. You don't have to have methodology, but I love it because it's just
Mhm.
brilliant. So from that, you can also build on equivalent fractions. So for example, the red is equal to 2 whites, which is 2/10. So 2/10 is equal to 1/5. The green is 3/10. And the purple is 4/10. And it does help with building equivalent fractions. You can also use this and say, okay, find all the pairs in which one rod is 1/3 of the other. Well, if I go back to this and reset, I could say, okay, if this is 1, which one of these would be 1/3 of it? No, 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 no. Hey, that wouldn't work. This is 1, and you would just play,
Mhm.
and there we go. I can see that the green and the blue, you can put the blue into thirds. Why? Because, okay. And the other thing is, this really builds on the fact that 3/9, you could use this and build 3/9 is equal to 1/3. And you can extrapolate and do equivalent fractions. So, very quickly here. You could, well, with your rod pair, sorry, you could find all the pairs that are 1/4 of each other, or 1/5 of each other, 1/6 of each other, 1/12. Brown, okay, let's see. No, I'm just gonna go fast here. I've done these. And then, oh yes, convince me that 1/4 is not always equal to 2/8. Well, just like that half, I said, one is a half, not always a half. It all depends on what is the whole.
Mhm.
Okay, so in one case, that little white cube could be a 10th, it could be a 9th, it could be an 8th, it could be a 7th, it could be a 6th, 5th, 5th, it could be anything. It all depends on what is the whole. And do these two fractions represent the same amount? Why or why not?
Well, in blue, that would be the same fraction, but doesn't represent the same area or area.
Well,
It's a quarter, but it's not the same size of a quarter because of the whole.
okay, they're both a 4th.
Yes, a
But
fourth.
the 4th, they're both different amounts
Yes.
because they are different sizes. Okay, just give me okay. So then in grade 5, they do improper fractions and mixed numbers. So this was 2 3/4. And we show them how switching that whole thing, but just by doing the partitioning, they can have 11/4. They also start in grade 5 adding and subtracting with like denominators. Now, if they know and they are strong in their partitioning and strong in their unit fractions, this is pretty simple. And then we do things like 3/4 plus 2/4 and on a number line. And we can also do it using our Cuisenaire rods on our things or on graph paper. 1 2/5 and 4/5 will give us 2 1/5. And then this is just what they've been doing in grade 5. But unfortunately, your kids haven't seen this before. This is new to them. And also even just doing the subtracting. Now we get to grade 6, where you've got 3 outcomes with fractions that we have to cover in the next 15 minutes. Students relate fractions to quotients. And I'll tell you, this was difficult for some teachers to understand, because what the outcome is that we're going to model an equal sharing situation in more than one way, and also you model a fraction of a natural number. Now, one of my colleagues who used to be with Edmonton Catholic, she made action verb cards that go to our skills and procedures, and you'll notice I highlighted the action verb, what students should be able to do. They should be able to model, describe, express, convert fractions. And so she made these cards for you. And now this one is from the K-3 verbs, because they started to model in K-3. But another one is describe an equal sharing situation using a fraction. And this is the definition of describe. This is express a fraction as a division statement and vice versa, or express 2 fractions with common denominators. And expressing something means that you're showing that your knowledge and understanding. When you have to convert a quotient from a fraction to decimal form using division, that's to change a value or expression from one form to another. So the fraction notation developed, I don't know if you know this, as a shorthand way to show the division sign. So something like 3 divided by 4 became 3/4. And as a fraction, that is written as 3/4. Now, this is often overlooked by students, and I am a First Steps in Math lead, and this is one of the things that we really try to make sure teachers are aware of. This is that the fraction notation developed because of a shorthand for division. So when you say share, this is for the grade 6 outcome, share 4 chocolate Mars among 5 people. So that is 4 divided by 5. And as a fraction, that's written as 4/5. You don't have to do any math. You don't have to do any longhand. If you just write it properly, it's 4/5. How much of, if you had 4 chocolate bars, 4 Aero bars, and you're going to divide them among 5 of you, it's 4 divided by 5. And as a fraction, it's written as 4/5. That's the answer. And so a lot of teachers actually make their kids do long division. There's some math you don't have to do long division for. So then 4 things can be shared equally among 5 people. So it's 4 divided by 5, or 1/5 of 4. And then you get 1/5 plus 1/5 plus 1/5 plus 1/5, which is 4/5. And then you can extend that to linked fractions and decimals. And I don't know why I'm missing, I am missing some, I'm going to have to get out of here. Sorry. I'm going to have to exit the slideshow because they are there. Do you notice that? So you extend this to process to link fractions and decimals. And what I mean by that is, let's say, oh, honestly, this is so sad. Okay. I'm just going to go back to, and I knew that we're not going to finish everything today because there's so much. There is so much that in grade 6 that they need the background for. So, for example, 3/10 can be written as 3/10 or 3/10. 1400ths can be written as a fraction or as a decimal. 172 thousandths can be written as 172 thousandths. And again, we can write in words 2/10, and it could be as a decimal or as a fraction. 35 hundredths. And those are easy ones because they have a denominator, or the decimal is easy as a tenth, a hundredth, or a thousandth. So those, if you say them properly, kids shouldn't have a problem writing it as either a decimal or a fraction. And then what I like is this one is, now what your job in grade 6 is, you get fractions like this that you have to convert to a decimal. And so before you go into long division, before you say 2 divided by 5, ask the students, can we change that fraction, 2/5, can we change it to something with a 10 or 100 at the bottom, the denominator? Yeah, we can. This is equal to 4/10. So if this is 4/10 as a decimal, can I write that easily? And then have them take out their calculator and just say 2 divided by 5. And let them see the surprise on their face when that happens. Okay, what about 14/25? Well, I'm definitely not going to change it to a 10 to tenths, but can I change it to 100? Yes. 14/25 is equal to 56 hundredths. And then you can show them that what I did was I multiplied the denominator by 4. So I'm going to multiply the numerator by 4 also. When I'm doing something like this, I don't want to show them the math yet. I want them to develop the understanding first of how this happened, so they can tell you, oh yeah, these equivalent fractions. So this is 56 hundredths. Can I write that as a decimal? I sure can. Or 315 over 500, or that was not said properly, 315 500ths. Oh, that's brutal. It's equal to the thousands though. It's equal to 630 thousandths. And I can write that down. But guess what else I can do? 630 thousandths. If I took off that 0 at the end, does it change the value of that decimal? No, not at all. So have your kids use a calculator to make connections between a half and a decimal notation, 5/10. For example, if a student shows 2 and 5/10 on their calculator, say, oh, that's the same as 2.5. Refer to 50% as equal to half of 100%, equal to a whole in appropriate context. And then link those fractions and decimals on a number line for them. And also, this is from our session that we had on place value, that you can link those decimals and fractions easily for them. And again, fractions representing division, 18 over 25 or 18/25 is the same thing as 18 divided by 25. And then they have to learn to add and subtract fractions within 100 using these terms: recognize, determine, add and subtract, and solve problems using adding and subtracting of fractions. So again, they did this in grade 5, but now you're going to use manipulatives, and you're going to help them understand how to do 1/10 plus 2/5. And they're going to have to convert something to an equivalent fraction. And so when I do this, and I'm just going to say, if this is my 1, and this, I've done the 1/10, hold on, come on. And of course it doesn't want to work. Why is it doing that? Okay, this is 1. And this 1/10 plus 2/5 2/5. Is this 2/5? Yeah. Well, I can see that that is equal to a half. But I can't just do that. What I have to do is I have to convert this 2/5 to my tenths. So 2/5 is the same as 4 of these tenths. And so that now I can see that this, oops, come on, is equal to 5/10. And 5/10 is equal to a half. Okay, Isabel?
That's a question. I do love the manipulative and the rod. I found it's excellent. But when they play on that, would you let them play with the rod on the background of a graph paper? right
Absolutely.
at the start, or no?
Sure.
Because grade
course.
6, I think it can help them to see the number right away.
Yep.
Okay.
Yep, for sure I would. Absolutely. Why not? Don't make life difficult for them. Now, you know what I'm really sorry about is that we did run out of time, because I want to show you that we can actually make it really easy by even converting and using the money model. So I promise I'll just show you this one, because this one is super, super fun. For example, a $50 is equal to what? 50 cents, right? A $50, a $0.25 or 1/4 of a dollar is equal to
25.
1/10 of a dollar is a dime.
Time.
1/20 of a dollar is 5 cents. 1/100 of a dollar is a penny. Now, this is also good because you're getting kids to think using money. But I would caution you not to go into this too early, because these are not, you'll notice they are not, the size is not really related to the size of the value or the value. But this is great when you're asking them, because there's some math, you don't have to actually use common denominators to add. You can think about money, especially if you're dealing with a halves, fourths, tenths, 20ths, and hundreds. Watch this. Let's say I have a half plus a quarter. Think of money. What's a half? 50
50
cents plus 25 cents. What do you get?
75 cents, 3/4.
Yes. 75 cents is equal to 75 hundredths, or it's equal to 73 quarters. Or this is where kids will go, you mean 1/4 is equal to a quarter? Because is that why a quarter is called a quarter? Because it's a quarter of a dollar? Yes, that's exact, because it's 1/4 of a dollar. So what about 3/4? Now, this is where I say, I'm really sorry I'm using that slash. I was just trying to get these slides done. And these ones are here are all just pictures of the fraction. But 3/4 would be what? How much? It would be 75 cents plus 50 cents, which is
125, 1 1/4.
right. Beautiful. 1 3/4 would be 1 3/4 plus a half. What's that in money?
Well, the kids could also do the half. They could do 2/4, because the half, we don't see that commonly in the language.
Absolutely. Absolutely.
2 1/4.
Isn't this beautiful? And guess what? I didn't have to use it's just there. So, and then my last one, I'm sorry, I'm gonna just go to this. You can also use your clock in your class. What's a half an hour.
Mhm.
Okay, these are really good for multiples and factors of 60. So for example, that's a half an hour, 30 minutes.
Mm.
Quarter of an hour or a fourth of an hour is 15 minutes. 2/4 are 30 minutes. 3/4 is 45 minutes. And this is also, you can talk to quarter to or quarter past. But anyway, a third of an hour is 20 minutes. 2/3 of an hour is 40 minutes. A sixth of an hour is 10 minutes. And by the way, you're getting all these slides. So I know. And like, I can't believe you guys are staying on. It's already 5:18. Okay. But a 12th of an hour is 5 minutes. And so here's all your equivalent fractions. You've got the 12ths, you've got the 6ths, you've got the 4ths, you've got the 3rds, and they're all equal to minutes too. So look at this. This is beautiful. I can say 1/2 plus 1/3 is equal to 30 minutes plus 20 minutes. What is that? 50 minutes. How much is 50 minutes of an hour? 50/60.
5, 6, yeah.
Okay, what's 1/6 of an hour?
10 minutes.
10 minutes. Oh, shoot. Yeah, I ran out of time here too. 10 minutes. What's half an hour?
30.
30. So 10 plus 30 is 40 minutes. So it's 40 out of 60. I mean, not out of, it's 40/60, which is 4/6 or 2/3. Like,
Wow.
there's some
Mhm.
that you don't have to, you really don't have to. There's brilliance in this. And then multiplication, please know that you don't have to do multiplication of 2 fractions. You're multiplying this. Now, using the definition, and this definition runs its course once you start multiplying a fraction by a fraction. But this is, multiplying is, what's just to add equal groups. So 5 times a third is the same thing as a third plus a third plus a third plus a third plus a third, which is equal to 1 2/3. 3 times 3/7. Aha. So now when I have something like this is where I really want to get to use my Cuisenaire rods. Because this is actually equals to 1 2/7. Now, but what you are doing is a fraction of a whole number. So when you think of this, when you are doing 1/4 of 16, please know that that's the same thing as 1/4 or one. See, here I go with my quarters again. 1/4 times 16, which is, think of the set model. You've got 16. You are going to partition it into 4 equal parts. How much is in each equal part? 4. But guess what? You also want to help your kids see this. 1/4 times 16 is the same thing as 16/4, or 16 divided by 4, which is 4. Alberta Ed has bought you rights to use gizmos. And so these are some really beautiful gizmos that you can use online. This one is estimating sums and differences. This one is fractions with unlike denominators. The Calgary Board of Education has put together a bunch of math tasks that they are sharing with you, and everyone that's underlined is a hyperlink to the activity. And I've given you the link to this math task. Edmonton Catholic, I know that we have people here from Edmonton Catholic. I know that you've done curriculum crates, and for all the subject areas, not just math, but if you went to this link, you can, they've opened it up to all of us teachers in Alberta. You can go to the curriculum crates and you can find activities there also. I also have a Wakelet full of math fraction resources that I am sharing with you in this document, and I'm going to give you this document before anyone has to really leave, and it is in the chat. I am giving you this document with a bunch of my own resources, and you'll find the clock model there and the other model. And also there are lots of sessions still coming up to help you with your math, grade 6 math. Honestly, I know that it is, there's a lot of work to be done, especially, I'll be straight up here. Larissa is my niece, and Larissa is first year grade 6 teacher. And I keep telling her that your kids in grade 6 are not really ready for all the outcomes. And please don't think that, it's because they don't understand. It's because they haven't even been given an opportunity yet to understand. And so we do need to go slow with them. And so you may not get to the grade 6 fraction this year, and don't worry. If you got up to the grade 5 fractions, it'd be a bonus. But you can see there's really not much of a transition from a grade 5 to grade 6. If they really understand unit fractions and partitioning equal amounts, they should be able to get anything. But there are some sessions, so please do come to them. Thank you. And I am so sorry that I have taken your time up from your evening, but there's just so much. Like I said, this is a really full packed session. If there's anything I can do for you, oh, that's not my email address. It should say urlc.ab.ca. I got to fix that right now. It is on this sheet though. I'll just bring this sheet over here. Your interactive slides are there. There's the glossary sheets from Tammy. This is the Rethinking Fractions book. This is the registration if you wanted to spend the $100 and go to the session by the authors. There's the Orgomath videos. This is the learning progression. Here's some interactive things, and I'm just going to go to the email that, the Math Learning Center. I'll just put this on too, and then you'll have this one also. Where is that? This is to make sure it's all in one place, Math Learning Center. There we go. And then your numbered outcomes by ARPDs. Plus, don't forget, ARPDC has a lot of stuff there for you. And Calgary Resources and Edmonton. And then the gizmos that I talked about. There's my slides. There's my Wakelet. There's all the upcoming math sessions. And that's how you can contact me at my email address if you need any help whatsoever. On that note, thank you. If you want to stay on, if you have any questions, please do. I'm just going to stop the recording. And whoops, no, stop the recording.